In this video, we're going to introduce and discuss the process for how to factor a trinomial, specifically something of the form x squared plus bx plus c, where the leading coefficient in front of the x squared is just 1. So for example, when we multiply the quantity x plus 1 times the quantity x plus 8, we obtain x squared plus 9x plus 8. Do we buy that? X times x is x squared. X times 8 is 8x, 1 times x is x, 8x plus 1x is 9x, and 1 times 8 is 8. Okay, yes, x squared plus 9x plus 8 is what we get. So the goal of factoring is to write the polynomial x squared plus 9x plus 8 as a product of two factors. Namely, in this case, the factors would be x plus 1 and x plus 8. When we multiply those two things together, we get x squared plus 9x plus 8. So in short, we're trying to reverse the process of FOIL. So if we have a trinomial, can we factor it into the product of two binomials? Okay, so when you factor, we're writing x squared plus bx plus c as x plus or minus something times x plus or minus something, right? So it kind of depends on what the sign on b and c is as to whether or not we have a plus or minus and in which category. But we know that x times x is x squared, right? It's a matter of finding those two additional numbers. What are they, right? So the goal is to find a pair of numbers whose product is c and whose sum is b. Okay? So that's what we need to fill in those blank spaces with a corresponding pair. If those numbers don't exist, then the trinomial is prime, meaning we can't factor it. It's not factorable. So let's try to use this process to factor x squared plus 9x plus 8, right? Okay, we already know what the factors are, right? I gave them to you. It's x plus 1 times x plus 8. But using this process, let's think about it. Okay, so we know that since we're adding everywhere, we're going to have x plus something times x plus something, right? So we're just looking for what those two numbers are. Okay, now what are the factors of 8? Well, 1 and 8, 2 and 4, right? Now, there's also negative 1 and negative 8. Negative 1 times negative 8 is positive 8, right? And negative 2 times negative 4 is also positive 8, right? But when we add these together here, 1 plus 8 is 9, and 2 plus 4 is 6, right? Negative 1 minus 8 is negative 9, and negative 2 minus 4 is negative 6. Okay, which one do we want? This is our winner, right? So with 1 and 8, we would have x plus 1 times x plus 8. Okay. Now, the other thing that I can account for, I did this other set of a negative times a negative because a negative times a negative is a positive. But when I look at the middle term, 9x is positive, right? So any time you're adding two negative numbers together, you're going to get another negative number. So we don't even really have to account for that. Okay, but between all the factors of 8 that I could come up with, 1 and 8 was the most appropriate because the sum of 1 and 8 is 9. All right. Now, another thing that is useful, I never learned how to do this when I was learning how to factor, but it's a method growing in popularity, and that is this little treasure map. So we listed all the factors. You might not want to do that every single time. So if you know I'm looking for two numbers whose product is 8 and whose sum is 9, and you just kind of think of those, well, 1 and 8 does it, right? Because 1 plus 8 is 9. If just having that visual on it helps you, that also can be very useful. Okay, so that's the gist of factoring. When the leading coefficient is 1, you just have to think about what multiplies to give you that last constant and adds to give you the coefficient on the middle term. Okay, so we're going to get a lot more practice doing this. Before we go there, I want to do just an aside. We're going to do a lot more with factoring by grouping when the leading coefficient isn't 1, But you can do factoring by grouping when the leading coefficient is 1. So if we take something like x squared plus 9x plus 8, and we rewrite the middle term. So we discovered that the two numbers whose product is 8 and whose sum is 9 are 1 and 8. So if we use those numbers and we rewrite the middle term as x squared plus x plus 8x plus 8, and it doesn't matter whether you have x plus 8x or 8x plus x, it'll come out the same way. Okay, so all I did is I took those two numbers that I needed, the 1 and the 8, and I just rewrote the middle term. Okay, now do the factor by grouping. So group the first two terms and the last two terms. In the first grouping of x squared plus x, I can pull out an x. Yes? So I'm left with x plus 1, right? 1 times x is x. And then in the second grouping, I can pull out an 8, right? That's common to both. And I'm left with x plus 1, right? 1 times 8 is 8. Okay, now x plus 1 is common to both of those, so I can pull it out. And I can have x plus 1 times x plus 8. Let's do that again. I just want to show you something because it's really cool. If I reverse the order on those middle terms, because I said it didn't matter whether you had x plus 8x or 8x plus x, let's do it the other way. So in this case, if we group the terms, in the first grouping, x squared plus 8x, I can pull out an x, right? And I'm left with x plus 8. And over here with x plus 8, there's nothing to pull out, right? And when there's nothing to pull out, remember, you got that 1 there out in front. So now I can factor out an x plus 8 from both terms. And I'm left with x plus 1. Okay, so I get x plus 8 times x plus 1. Now, it's the same product, x plus 1 times x plus 8, x plus 8 times x plus 1. It doesn't matter, right? Multiplication is commutative. But I just want to show you that that's sort of a scenic route around getting there. And when the leading coefficient is 1 like this, I think it's the long way around, and I would not want you to do this. I would want you to stick with this method. Just ask yourself, hey, what two numbers multiply to get C and add to get B? And those are your factoring numbers. There's no need to go through that whole song and dance, but I wanted to relate it back to the factor by grouping. And when the leading coefficient isn't 1, then there's more to talk about with that, and we'll get to that. But at any rate, for now, let's concentrate on trinomials where the leading coefficient is 1 and get some more practice.